Hi everyone, this video is going to talk about change of base problems. So change of base problems are really going to be dealing with logarithms. But first, our problem normally looks like an exponential problem where we have a base to some x exponent equal to something. But the problem is we really don't know what, for example, in number 1, 2 to what power is going to give us out 5. We know somewhere in between when x equals 2 and x equals 3, that's going to happen, but we're not entirely sure that precise value. So when the exponential form does not help us, we want to convert this to logarithmic form. So logarithmic form is going to be log base 2 of 5 is going to equal x. But now we run into another problem. We have log base 2 of 5. Using our calculators is not very handy right now with that form because we only have a log base 10 and a log base e button on our calculators. So we need to find a different way to solve what log base 2 of 5 is. And luckily we just learned that. We learned this change of base formula where you're going to take the log of what was ever in the log divided by log of whatever the base of your original log was. Notice how the base is lower and the base is now the log on the bottom of the fraction. That's how I keep those straight. But anyway, we want to now apply that right here. So we're going to change this to be log base 10 of 5 divided by log base 10 of 2, and that's going to equal x. So when you type that into your calculator, you will get out approximately 2.322 is equal to x. So if I take 2 to this power, putting it right up there, it's going to equal 5, about, just because we rounded. Okay? So when we run into problems like this, we want to be able to use this property to help us solve them, this change of base property. So looking down here at number 2, we have 8 to the x equals 9 squared. Now we want to find what exponent is going to give us 9 squared out. But the problem is we don't even have the same base running around. If we had the same base, for example, if we had 9 to the x equals 9 squared, well, we know x would have to be 2. It's just common sense. If the bases are the same, the exponents have to match in order for this expression to match. So that's what we're going to do right now. We're going to pick one of these two bases and change it into the other. I'm going to pick 8. So I want to look at 8. Don't look at this anymore. I want to look at 8, and I want 8 to be equal to 9 to some power so that I can replace it so it looks similar to the other side. So that exponential form isn't really helping me much, so I'm going to change it to logarithmic form. So, So this would be log base 9 of 8 is going to equal x. Again, that form doesn't really help me because I don't have that button on my calculator, so I'm going to have to use that change of base formula. Log of 8 over log of 9 is going to equal x. And when you punch that into your calculator, you're going to get out approximately 0.946 is equal to x. Now, this isn't the x that's over here. This is really the x that goes with this 9 up here. So 9 to this power is going to give us out 8. So whenever I see an 8 over here, I'm going to switch it with 9 to this power. So I'm going to put a little dividing mark here so we're not running into things. So that 8 is now going to be a 9 to the 0.946 power. And that's going to be equal to, well, it was equal to 9 squared. Now, there is a common mistake that people make. You substituted in this for 8, but notice that it's 8x. So I have to still put it to the power of x right here. But we can use our properties of exponents to simplify that a bit. We can say that's 9 to the 0.946, and when you have a power to a power, you're multiplying, so times equals 9 squared. Look, our bases are the same, so now the exponents have to match. So I'm not even going to think about the bases anymore. I'm just going to look at the exponents. When do they equal? Well, if I have 0.946x equals 2, I'm going to divide by 0.946 to either side, and that's going to give me approximately 2.113. So 8 to the 2.113 is going to give me out the same thing that I would have for 9 squared. So test that in your calculator if you don't believe me. All right, let's go over here and do the same thing. We have 4 to the x plus 2 equals 6x. So not the same bases, let's make them the same bases. I'm gonna pick 4. I wanna think of 4 is equal to 6 to some power because I want both my bases to be 6. So 4 is gonna be equal to 6 to some power. What is that power? Exponential form doesn't really help us, so I'm gonna go with logarithmic form. So log base 6 of 4 is equal to x. Use our change of base formula. Is equal to x. Typing that into your calculator, you're going to get approximately 0.774 is equal to x. Now remember, this is that x. That's the exponent for the 6. So wherever I see a 4, I'm going to write 6 to this exponent. So right here I see a 4. Again, I'm going to put my divider in. So 6 to the 0.774 power. That's in place of my 4. But I still have to write what I still have 4 to the power 2. I still have it to the power of x plus 2, and that's equal to 6x. So we have a power to a power, so that means I can use the multiplying the exponents, so I'm going to have 0.774x plus 2 times 7.774, which is going to be 1.547. I did this ahead of time, so that's why I know that. Didn't do it off the top of my head. Is equal to 6x. Our bases are the same, so these expressions are going to be equal when their powers equal. So I have 0.774x plus 1.547 is equal to x. I'm going to get my x's on the same side, so I'm going to subtract 0.774x to each side. I'm left with 1.547 is equal to 0.226x. Now I'm going to divide by 0.226, and when I do that, my result is going to be approximately 0.845. So this exponent right here, this x value, if we put it in up here for both of these x's, those expressions should equal the same thing. All right, let's do one last one. Here I have a base of 3, I have a base of 7. I'm going to go ahead and change this 3 into 7 to some power. So I have log base 7 of 3 is equal to x. Use my change of base formula. That's approximately 0.565. So this x is really 7 to some power to get me to 3. So whenever I see a 3, I'm going to write 7 to that power. 565 about. I still have that to that x minus 5 power. And here I have 7 to the 2 minus x power. Use my properties of exponents to combine some things here. And when I multiply this by 5, I'm going to get out 2.823 is equal to 7 to the 2 minus x. Go ahead and notice that the bases are the same, so these expressions are going to be equal and the powers are the same, so 0.565x minus 2.823 should be equal to 2 minus x. Now I'm going to go ahead and add this x to the other side. I'm going to go ahead and add this plain old number to the other side. I'm running out of room. So those x's are gone. That's gone. So I have 1.565x is equal to 4.823. Now I'm going to divide by 1.565 to both sides, and x is going to be approximately 3.083. So go ahead and try that one as well. So change of base problems, look at what base you want to change. Again, it doesn't matter. You can change the 8 over here. You could change the 9 over here into an 8. It doesn't matter. You just pick which one you want to work with. But other than that, these are the types of problems you're going to be dealing with when we have to change base.